The basics of matrices. You may not have ever used a matrix before, but today you're going to be using it to solve a system of equations. And you've solved systems of equations before. You did it with the graphing technique, substitution, addition, and elimination. And so this one just shows you an alternative method with some technology. In your textbook, they'll show you how to solve this by hand, and I highly recommend you use technology. If you choose to do it by hand, that's your own choice, but I'm recommending technology. All right, so for some basics, a matrix is a rectangular array of numbers. We're going to be using an augmented matrix. This simply means that there's a vertical line that's drawn in the matrix to separate certain columns. Our vertical line will always happen right before the last column. The vertical line for us is placed where the equal sign would be. So for example, if I have a system of equations that reads 7x plus 9y equals -1 and 2x equals 5, I take that very first equation and then I write it in the first row of the matrix where I'm using just the coefficients. So I write 7, 9, and -1. I have that vertical augmented line where the equal sign would go. Then on the second equation, which reads 2x equals 5, I would notice that there's no y value, or y term, that would be more correct. So I would put a 2 for the x's coefficient and a 0 for the y's coefficient, since there was no y term. And the 5 is on the right-hand side as our constant. So the system of equations that's provided on the left is now written in a matrix form with an augmented line. I'm going to take a look at one other equation down below. We have a system of equations that has 3 equations, and so our matrix needs to be a little larger. And the first thing I do is make sure that all my equations are arranged in the right order. That very first equation, 3x minus 6y equals -9z, is not in the correct order. I need all my variable terms on the left side of the equal sign. So I'm going to add that -9x over as a positive 9x. And on the right-hand side, there's no value, so I place a value of 0. The second equation, all the variables are on the left, and they're also in order alphabetically, x, y, z. So that second equation is good to go. In the third equation, I see that I have a y on the right-hand side. I need to move that over and place it in between the x term and the z term. That means that my third equation becomes -2x minus y plus z equals 7. All my equations are now in the correct form. Now I can write it into a matrix. You're going to notice that all of the coefficients from the x terms are written in the first columns. So sometimes people prefer to write a x above that first column to remind themselves that that's where all the coefficients for x go. And then the second column has all the coefficients for y. The third column has all the coefficients for z. And the fourth column has all the constants. Another way I like to write this is I like to take that first equation and write it across the first row, remembering just to write the coefficients. The second equation is the second row, and the third equation is the third row. So that's how you take a system of equations and write it into a matrix.